All right, gentlemen, if you're ready, I think we'll officially get started. All right, hello, everyone, and welcome to today's OSMINE webinar featuring AVEVA together with Rio Tinto, who will be presenting on the future of mine design with AVEVA E3D. My name is Tammy Pisani, and I am the OSMINE State Manager for Queensland, and I am delighted to be your host today. Before we begin, I would like to acknowledge that I am hosting this webinar from Brisbane on the traditional lands of the Yagara and Turrbal people. I also acknowledge that the traditional custodians of the various lands on which we all work today and the Aboriginal and Torres Strait Islander people that may be attending this webinar. From AVEVA, we're joined today by Ricardo Tenalia, Global Account Manager, and from Rio Tinto, we have David Kettle, 3D Modeling Application Specialist. In this session, Rio Tinto will share how AVEVA E3D is being used in conjunction with Deswik MDM to optimize detailed engineering of mine infrastructure in context with the vast geoscience dataset, enabling real-time collaboration and decision-making across disciplines and engineering teams. This presentation will go beyond traditional fixed plant design, showcasing a smarter, more connected way to design the mines of the future. I want to remind everyone that during AVEVA's presentation, please feel free to submit your questions at any time. You'll find a Q&A button at the bottom of your Zoom interface. And at the end of their presentation today, we'll do a live Q&A with David and Ricardo. I should also note that this webinar is being recorded and will be made available to all attendees. It will also be on OSMINE's YouTube channel in the coming days. So with that, I would now like to hand it over to you, Ricardo. Ricardo, the audience is yours.
Thank you, Tammy. Hi, everybody, and welcome to our webinar today. We're actually really quite fortunate. This webinar sort of came about through a meeting that I had with David, where he was showing me some of the cool things that they're doing with our software, and it kind of sparked the idea that this would probably make great viewing for people that are interested in the future of mine design. It really is quite groundbreaking. Before we get into that, and before I hand over to David, what I wanted to cover with everybody is a little bit of a background on where you would have probably seen and heard. The AVEVA brand is sort of synonymous with the engineering design tools and E3D out of Cambridge. However, there's a lot of people in the mining industry that are probably more familiar with the AVEVA product stack or the AVEVA portfolio more traditionally in the operational side of the mining process, in the sort of the automation and the control area with our SCADA systems, whether it be Cytect or the Wonderware suite of products, the Pi Historian. Today is going to be really quite a different approach from an insight rather than the operational side of the business. And I guess when it comes to the mining industry in general, we tend to work as an organization quite closely with a number of the larger miners in the space. I personally have the privilege to look after Rio Tinto. However, as an organization, we have a very strong distribution of our portfolio throughout the mining industry in general. So taking it back to where the focus for the presentation today is, it's really in the beginning, in the early design stage of the mine process, and I guess to frame the context of what we're talking about today, I guess you could better describe what we're going to look at today as almost what we refer to as the AVEVA-centric digital project. And it really is a bit of a game changer when it comes to the design process, which is more traditionally an EPCM is engaged. The work is handed over to the EPCM, and then periodically throughout that design phase, deliverables are handed back to the owner, and then there is a sort of a growing and an ongoing discussion about the design of the mine. In this particular case, what we're looking at is a completely new, almost paradigm of how you would execute a project, where you either take what would normally be traditional on-prem software and you host it in the client's cloud environment, or you take the design tools and you put them into a cloud or a SaaS environment, either of which are possible with the AVEVA design tools. More traditionally, you would have tended to have problems not only in getting some of the agreement between the owner operator and the design organization, but you wouldn't have a lot of transparency, and you would tend to spend a lot of time agreeing on whether certain deliverables are completed to the necessary standard. In this particular approach with an AVEVA centric digital project, what you're doing is you're taking the client's, in this case, for example, Rio Tinto's own design specifications, and you're building them into a foundational document, essentially a conceptual model. That conceptual model is made available to the design institute, the EPCM who's doing the work. Typically, it would save them time up front, because they would save anywhere between 6 months and 12 months just setting up a lot of those basic standards. So they can basically hit the ground running. And then from that phase, there's a whole degree of transparency, because the client can actually see in real time what is being done in the design process of the project, which typically leads to significant savings for organizations because of that level of transparency. Today, we're going to choose a very thin or unique application for that AVEVA-centric digital project. And we're going to get David to kind of go into a lot of very specific detail between the value of being able to synchronize the underground construction process with, which is in a Deswik environment, with E3D, which is where you would develop all of the infrastructure for the mine. At that point, it's probably a good segue to hand over to David. Hope you all enjoy the presentation. I think we're very privileged to have him here with us today. And I'll hand over to you, Dave.
Yeah, thanks, Ricardo. Okay, so just to go through the agenda, we'll have a look first at the types of mine planning and engineering activities that we're aiming to merge into one complete picture. We've started this about a little over 12 months ago, and we've completed phase 1, where we've actually merged the Deswik MDM model with AVEVA E3D, and I'll show you some of that shortly. And then we're currently working on phase 2, which is to return some of that data from E3D back to Deswik, in particular for tax management. And I'll show you some of that towards the end of the presentation. So if you look on the left-hand side, these are the mine planning activities, which generally get done in Deswik. So all the mine planning and geotechnical teams plan all the mining activities together with lots of the geotech data, like fault planes, the boreholes and that kind of thing. And they generally engage mining contractors to actually do the mining, blasting and excavation works. And on the right-hand side, you can see this is actually part of the dewatering infrastructure in a mine. So the engineering teams perform all the engineering activities for this underground infrastructure. And again, they engage engineering service providers to perform the detailed design and engineering up to construction. So if we just have a look what some of these applications look like when you're using them. So Deswik MDM is what you're looking at here. And you can see this is a complete underground design of a mine. In the center, you can see there's a 3D model, but it's not just the spatial data in 3D that we're looking at. So on the left-hand side, you can see we've got a whole database complete with different data sets. And on the right-hand side, we've got sets of properties. So when you click on an object in the 3D model, you can see which data sets it belongs to and a list of all the properties in the database. And this in general is mine planning data. So a couple of things to note. In the 3D modeling part of the screen there, most of the underground design involves irregular shaped solids. And a lot of the surveyed solids are watertight triangulated surface meshes, and they're completed after doing basically LiDAR scans underground. And they use a process to triangulate the point cloud data into a surface mesh. And a lot of this data is derived from sensing and measuring of real world conditions with some direct input as well. And just to reinforce, this is all based on an intelligent database system. So it's not just the 3D solids you're looking at all the data which is associated with those 3D solids as well. And in a similar vein, AVEVA E3D is used for 3D layout, design and modeling of the underground infrastructure. So again, we've got the 3D model in the center of the screen there. We've also got a database view, because again, all the 3D solids are linked to database objects, and the database objects have all the physical and geometric properties and material properties which you need for design and construction. So most of the solids which you see in the 3D view are regular shaped solids, and they're generally defined with parametric definitions. So you can use formula and parametric data to describe the shapes which you're seeing in the 3D view. And most of that data is derived from industry standards, catalogues, and again, direct input by the designers and engineers. And again, just to reinforce, AVEVA E3D is also an intelligent database driven system. So what we need to do is, because both systems are they're slightly different sorts of data, the software which is developed over years is optimized for the particular sorts of data sets which you're viewing, particularly in the 3D side of things. So we look at the right-hand side here. This is Rio Tinto's implementation of the AVEVA Unified Engineering toolset. Today, we're particularly talking about AVEVA E3D, which is the 3D modeling for the infrastructure. But we're also connected to AVEVA Engineering for tag management and the class library. And we also have 2D data for AVEVA diagrams, electrical and instrumentation schematics. And all this data sits within the Dabacon database. And we use a system called Compare Update to make sure that all the data within the AVEVA tool set is synchronized. And the complete set of data there is hosted in Azure, what they call virtual desktops. So we can roll out virtual desktops to anyone working on particular projects, and they already have all of this software and all the different database tools installed. Just a note on the Navisworks. We use Navisworks or BIM 360 on a lot of projects for 3D model reviews. So Navisworks is quite good at merging 3D model formats from lots of different systems, but it is just a model review tool. So you can't create new models in Navisworks, and you can't generate any deliverables from Navisworks. So what that means is, if we want to merge the Deswik mine planning and infrastructure data sets with the E3D data sets, we have to bridge the gap between the two. So you can see on the left-hand side here, we've got Deswik MDM, and then that actually consumes data from Leapfrog for all the geological data, Deswik CAD for the mine planning data, and Acquire for the drilling data. So in phase one, we started this just over 12 months ago, and we've completed this now. So now we can get a complete copy of the Deswik MDM 3D underground model into AVEVA E3D in the same coordinate system as the infrastructure 3D models. I'll show you what that looks like shortly. But one thing to note here on phase one, prior to automating this step, with the interface we developed between Rio Tinto, Deswik and AVEVA, it took about 14 human hours to do manual copying of data, and the frequency was every 1 to 2 months. So any data we had on the E3D side was always 1 to 2 months out of date. After we've implemented the phase one interface, it's completely automated. So there's no human hours needed to do this, and the frequency is every 24 hours. So you know the data in the AVEVA E3D model is always synchronized with the Deswik MDM data. And then I'll talk a bit towards the end of this presentation. We're going to implement phase two, where we'll actually get some of the coordinated 3D model data from E3D back into Deswik MDM, and there's particular reasons why we need to do that, which I'll show you later on. So we'll talk about phase one, which is about passing the mine planning model from Deswik MDM into E3D. So I've got a video just to show you, which is a fly-through of the Kennecott mine in Utah, in the US. A couple of things to note before we start. It's only about 40 seconds long, but you can see there's purple translucent objects in the middle of the screen there. They're the fault planes taken out of Deswik MDM. And then as we zoom in closer, you'll notice some light sandy brown objects, which are the design model in Deswik MDM for the mine planning model. And the dark brown objects are the surveyed and triangulated surface meshes from the surveyed data. So if I just start that now.
Look at the scale. Wow.
Okay, so I hope you can see from that brief fly through, it's really quite a large scale in 3D spatial scale. And we do have quite a large data set from Deswik MDM in the model there. And the infrastructure we flew through was part of the dewatering infrastructure and electrical supply system. And so that should give you an idea of the scale of the underground model in Deswik MDM and how we fit the engineering infrastructure in position with the underground model. So when we talk about copying the 3D model data from Deswik MDM into AVEVA E3D, the first thing we have to overcome is that both systems use proprietary 3D model and data formats in the database. There is no cut and paste. So like you cut and paste between Microsoft Office and PowerPoint or Excel, you can't do that with these 3D intelligent modeling systems because they're different proprietary formats. But both systems do have import interfaces for various different 3D model formats. And they also both have integrated programming languages, which enable you to automate tasks. So on the right-hand side there, you can see for AVEVA E3D, the multi-CAD import interface. There's about 24 different formats we can import from other systems into AVEVA E3D. Some formats are more successful than others, and some formats do have an impact on 3D performance in AVEVA E3D. So we did do some work to find out the best formats to give the best results. Just before we look at the formats in more detail, on the left-hand side, I've just highlighted the Deswik MDM datasets for the underground mine planning model. On the interface, we have different datasets which we import into E3D at different rates. So for the design model in Deswik MDM, for the short-term planning and life of mine models, they're relatively simple 3D geometry because they're the design drifts, which are basically the cross-section of the tunnel shape. And the survey models, they're the complex 3D triangulations from the point clouds. We replace all of these in E3D every day. So every 24 hours, we update the complete model. We don't actually need to update the complete model. We look what's changed in Deswik MDM, and then we only update the objects in MDM which have changed since the day before. So we do keep we keep a link between the E3D solids and the Deswik MDM solids, so we can always trace them back between the two systems. Some other data sets which we update as and when we need to. We have some historical mine data, as I said, borehole data, faults, lithology, grade shells, and the open pit topography. So we update them as and when we need to. So the interface details between the two systems, as I said, both systems have the ability to translate data between different model formats, but they're generally generic interfaces, which just deal purely with the geometry. So in the implementation we did for the Rio Tinto work, we make sure that Deswik MDM remains the master model for mine planning and geotech data. So we don't edit the model in AVEVA E3D at all, and that's crucial to keep both the models synchronized. We have a logical break between Deswik and E3D environments, and this is because there's a different team that manage the databases and the servers for both Deswik and AVEVA E3D. So we've designed the system so that if there's downtime on one system, it doesn't affect the other system. And we do provide configuration files so that we can change the data sets. We can add or remove data sets and change some other parameters. So for different projects, you can have a different configuration with different data sets. And part of the export and import process, we do actually transform the data because the data is used for different purposes in Deswik and in E3D. So some of the transformations we do are units conversion between metric and imperial. We do some Boolean operations and we do some decimation as well. And I'll talk about that on the next few slides. But if you look on the right-hand side, you can see the different formats we tried when we initially started testing the interface. So option 1 and 2 were basically solids. One was showing the holes in one complete block solid, and the other is just showing the individual solids. And then on the bottom, option 3 was hollow shells, so that we could actually show the shell of each drift with the designed engineering infrastructure within. And then if you look at the top right, You can see there that the Deswik model, all the straight drifts are actually compartmentalized, so they're in 36-foot sections. And that's because they use that data in Deswik to monitor progress. But we don't need that data in E3D. So one of the Boolean operations we do during the transfer is to do Boolean actions on all the solids to make them one single solid, so that we don't get all the walls along the straight drifts in the E3D model. And there's several other transformations we do as well as part of that process. So if we look at phase 2, this is where we need to pass mechanical envelopes from E3D back into Deswik. So this develops the initial idea of making the E3D modeling activities more efficient, because we can do it in the context of the Deswik 3D underground model as well. But when you look at the actual infrastructure modeling within E3D, sometimes you can see there a straight drift, which has come directly from the Deswik design model. It's not wide enough. It doesn't contain the whole airlock structures and some of the electrical gear. So what we do in E3D is when we lay out and design the infrastructure, we can put the smallest possible mechanical envelope around that structure, which means we can reduce the size of the excavation, and that saves obviously time and effort and schedule. But we need to get the mechanical envelope back into the Deswik MDM model. So the next phase, you can imagine, once we've passed the mechanical envelope back into Deswik MDM, they need to do the excavations and then scan the excavations to make sure that it is big enough to fit the mechanical envelope within the actual excavated drift. So after we've passed the mechanical envelope to Deswik, they do the excavation and then they scan the survey drift, and then we can compare the mechanical envelope with the survey drift. And a couple of terms there. Overbreak is where the excavation is bigger than it needs to be, and underbreak is where the excavation isn't large enough. So if we need to fit some of the mechanical infrastructure in the space of the underbreak, you can see at the moment the excavation isn't big enough. So we need to identify those as quickly as possible. And the other term I've used there is tights, and tights is where it's a tight fit, which means the surveyed drift is basically not big enough to fit the infrastructure in. So if you look on the right-hand side, this is a picture of an actual drift which has been excavated, but you can also note they actually coat the inside of the drift with shotcrete. Then they drive rock bolts into the walls and the backs at the top, and they put mesh around as well to finish off the excavation. Now, if you leave the comparison of the mechanical envelope and the survey drifts until after all this work is done, it becomes a very expensive and time-consuming exercise if you need to do a bit more excavation, particularly where the underbreaks are. So what we're trying to achieve with phase 2 is we get the surveyed model data and the mechanical envelope data into the Deswik MDM software as quickly as possible. And again, that will reduce the risk of any impact on the schedule and cost when they're completing the excavations. Okay, so we just look at the current status. We've phase 1 is complete, and we've been using that on the Kennecott project for about 12 months. So we're already seeing the benefits of this in the workflow at Kennecott. Phase 2 is currently in development for the Kennecott project. So we're working with Rio Tinto, Deswik and AVEVA again to complete the phase 2 side of things. And there's a possibility we may use the same development for resolution and Simandou projects as well, but that's not been decided yet. So I think that's that's as far as I wanted to go.
Yeah, perfect.
Yeah, do you need to say anything about that?
Yeah, I guess some of the questions that when we were originally talking, and I saw the early stage design of the mine, and probably for those that were looking at the fly through that we had, it's a very different mine in that there's a lot more use of electric vehicles underground.
Yeah.
And as soon as you start putting electric vehicles underground, you have issues with having to put the infrastructure associated with the charging stations. You also have a whole lot of dewatering equipment in massive caverns underground. And it seems to me that it is very different to how you would have developed a mine in sort of years gone by. Is there any sort of anything you wanted to sort of go into a little bit more detail around, you know, some of the amount of infrastructure that's going underground and why this is important?
Oh yeah, I mean, it's mainly the cost and schedule. So yeah, the mine planning and geotech teams are a different team than the engineering team. So when you're planning the mine, you've got to make some assumptions, and when you're engineering, you've got to engineer it to do the layouts and the layouts what you actually need. For example, for a battery charging bay. So if you can merge the two modelling functions, it assists with the discussions and collaboration between the two different teams, which again helps reduce the schedule and any costs which overruns and things like underbreaks in the excavations will cause.
Yeah, excellent. Okay, I think as per the format, I think we finished and finished the main content, and I guess we're in a position where we can start to. We'll open up the chat.
Yeah, fantastic. As a reminder to everyone, you can submit your questions for Ricardo and David. So please submit them now. I do have a couple of questions that I can ask. And I'll let you, Ricardo and David, decide who's best to answer. Can you use AVEVA E3D for above ground terrain or only underground?
No, yeah, you can use it for above ground terrain as well. And again, there's different ways you can do that. It depends where the terrain data is coming from. But we've got several interfaces with other systems which you're likely to use for civil works, for example, and then we can import that directly into AVEVA E3D for the above ground and for the open pit topography as well. Yeah.
Very good. And one more. What is the difference between AVEVA E3D and AVEVA Unified Engineering?
You go for that?
No, you're happy to jump in.
So unified engineering, well, that's actually it's one umbrella term which is used for all the different AVEVA design and engineering applications. So we've got 1D, 2D and 3D data generally. So you've got things like engineering key lists and data sheets for, you know, electrical, mechanical equipment. So that's 1D data. Then you've got 2D data, which is generally electrical schematics, instrumentation schematics, and P&IDs for piping systems. And then you've got the 3D modeling systems. But then you've got the database behind all this, and the update compare functionality, which lets you, based on the tag numbers of all your infrastructure and equipment, you can automatically update one app from the other app. For example, electrical engineering, you might update the electrical data from a schematic into AVEVA Engineering, where your master tag list is. So it's all connected, and AVEVA Unified Engineering, firstly, is the umbrella term for all those applications, but it's also the new name of the new application, which does contain all of those applications. So I don't know if you want to talk about that.
That's fair. I guess in layman's terms, unified engineering has this common, I guess, out of Cambridge, and I think that's why E3D is so popular today in the design of a lot of oil and gas platforms, and typically the oil and gas or shipping industry, and now becoming more and more popular within the mining industry, is this common database that called Dabicon, which lends itself to the management in a database format of all of the data sets that are needed across those 1D, 2D, and 3D platforms and tools.
Yeah.
All right, great. Thank you. Will would like to know, what does this mean for suppliers? To what extent would you have to use AVEVA if we're supplying a package in the above ground processing plant of a new Rio Tinto mine?
Yeah, I mean, that would depend on how big the package is and what sort of package it is. So if you're talking about, a particular process, so it's a whole part of the process plant, for example, then you might have different tool sets which the owner of that process would use to create their initial 3D models and all the other 1D and 2D data. But then, depending on the setup of the project, we might import that into AVEVA E3D using the import interfaces, or we might just link to it through other systems. So we use the AIM portal, for example. The AIM portal is a web-based tool that sits over all the other applications and databases. And again, you can link all the data in all the different systems using the tag numbers of equipment, which links it back to all the other data, which you can link into the AIM portal.
Yeah, and if you can imagine in a situation where somebody may have their ERP system, let's say you have SAP, and within SAP you've designed all of your functional locations, which is essentially a model of the capital equipment that's used in the project. As we move further and further into this kind of digital world, there is more and more of a need to start synchronizing those functional locations with the conceptual model within your mine and your mine design. And so what David was just describing there is the Asset Information Manager software application, which we refer to as AIM, which is now sitting above the data set for all of the mine design, but it's also allowing you to find those document to document, tag to document, and document to tag relationships. So when you need to find any data, not only in the engineering phase, but more and more in the operational phase of a mine, you can search and find all of the information that you need through a single interface, even if all of the applications underneath are not necessarily AVEVA tools. So it could be sitting on top of your tool set for drawing, but it could also be sitting and collecting data from a range of different data sources.
Yeah.
Very good. All right, Bruce would like to know, how do you find translating the global coordinate system from Deswik to the E3D localized coordinate system?
Yeah, so we actually use the Deswik coordinate system in E3D. So we use that as the base coordinate system. And then we have drift objects in the E3D model, which use a local coordinate system. So if you're doing a particular bit of infrastructure like the dewatering pump station, you set the datum relative to the Deswik coordinate system, but then you model in a local datum just within that one drift. So you can change the datums depending on how zoomed out you are within the whole model as a whole.
All right, very good. I think that is all the time that we have for questions. Ricardo, I'm supposed to remind you that you have 2 more slides to show before we close out today's webinar.
Yes, this is the bonus content for those people that have stuck around to the end. I guess a little bit of a plug here for those people that would like to scan this QR code. We will be sending through a copy of the presentation slides to you. Also, we'll provide a link to the on-demand recording, and then there'll be some E3 data sheets and additional information. And finally, I guess a little bit of a plug, not only for the IMARC event that will be present down in Sydney next week. Not next week, sorry, but the week after. But also for those of you who may be interested, similar to the webinar information that was presented today, AVEVA will be having our annual AVEVA event, or what we, just thinking, it's Pi World, so it would be AVEVA World. You can see I come from the Pi background. So we have AVEVA World happening in Milan early next year, and one of the specialties of that particular get together is that we typically have 1,500 to 2,000 people coming along, all of our customers presenting, and there's literally hundreds of presentations similar to what you just saw David presenting, where you get a chance to see what's happening in industry, some of the latest and greatest innovations. Typically with the AVEVA software and it working in the context of other software applications. So that's basically everything I wanted to cover. Again, I guess a heartfelt thank you to David for making his way in here, and really appreciate you coming in and doing it.
Yeah, good. Yeah. Thanks for the opportunity to present.
All right, thank you very much, gentlemen. Thank you. For those of you that did submit questions and we did not get to them, we will send your questions to Ricardo and David, and they can follow up directly with you to answer your questions. So I'm afraid that is all the time that we have for today. So I'd like to give again a big shout out to Ricardo and David and AVEVA and Rio Tinto for being with us today. Thank you for your time and sharing your knowledge with us. And again, a reminder to everyone that this presentation was recorded and will be available on the OSMINE YouTube channel. And of course, we'll send you a link directly. Thank you to everyone who attended, and I look forward to welcoming you to another OSMINE webinar in the future. Enjoy the rest of your day.
Thanks again, Tammy.
Thank you.